Hi folks, we're going to be talking about the distance formula today. We're actually going to be deriving it, which means we're going to be figuring it out based on something that you already know. So the distance formula is derived from the Pythagorean theorem, something that you are very familiar with, or at least you should be. If you want to abbreviate theorem to THM, then you're welcome to, but the distance formula is derived from the Pythagorean theorem. On the graph below, which you can see the graph below, but I don't have mine up there yet. On the graph below, we can find the distance from point A to point B using that Pythagorean theorem, which you have as a squared plus b squared equals c squared from your memory, from your earlier math classes. So point A, I'm going to go ahead and switch to my screen. Point A, right here, is located at the coordinate 6, 4. So point A is at 6, 4. And point B, here, is located at the ordered pair -3, -4. -3, -4. So once you have your ordered pairs written down, you're going to draw the slope triangle to create a right triangle. Remember that the slope triangle is drawn by doing rise over run. So on my graph, if I start at my left point and I rise up until I'm level with the next point, and then I run all the way over to it, perhaps I need to draw a line segment from A to B, I now have a nice pretty right triangle. So, something that you want to have labeled, because we are talking about the Pythagorean theorem, and the Pythagorean theorem involves side lengths. We want to label the side length. So this side length right here, from point B up to some point up here, that's going to be side length B, lowercase b. And this side length here that has point A as an endpoint, that's going to be lowercase a. So the distance from point A to point B, this unknown distance right here, in fact, let me change my colors, that unknown distance right there from A to B can be found using that Pythagorean theorem. So my distance B is 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to substitute 8 here. And my distance here, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to substitute 9 here. And that should equal c squared. This is my distance c. That's the distance that I don't know. So I'm going to go ahead and do my math. I have 9 squared, which is 81, plus 8 squared, which is 64, equals c squared. 81 plus 64 is 145. Oops, I'm so sorry. There we go. So 145. And then if I'm trying to calculate c, the distance, not c squared, the only way that you undo a squared is to square root. And that will undo or negate the squared and the square root. So we have that c equals the square root of 145. That's the distance. It really doesn't mean a lot to us when it's in that form. However, that is the distance from point A to point B. So the way that you found A, distance A, was just by counting, right? You found it by counting the x values. So you were counting sideways. So I found it by counting or subtracting the x values. So specifically, my x values, if this is the point 6, 4, and this is the point -3, -4, if I use my distance from the last class period, then I'm going to see I have the absolute value of 6 minus -3, which equals 9. That's my A value. That's what I substituted here. I found B by subtracting the Y values. So for the Y values, my distance between the 2 points from here to here, that Y value subtraction is going to be 4 minus -4. Well, 4 minus -4 is the same thing as 4 plus 4, so that's going to be 8, and the absolute value of 8 is just 8. So that's where I got the B value from. So we can find those distances by subtracting. We can also find those distances by counting. So in general, if you were not given numbers for the coordinates of point A and point B, you could use variables to represent each location. So perhaps you were unsure about what this point was and what this point was. You can use x1 and y1, x2 and y2 to denote the location of those points. The 1s are just for point 1 and the 2s are just for point 2. It really doesn't matter if these are 1s or 2s or if these are 1s or 2s, as long as together they are the same type. So these would both have to be 1s and these would both have to be 2s. They both need to be the same type to label as point 1 or point 2. So, as before, we have a slope triangle. Don't be thrown off because your slope triangle, or the one that we drew, was like this, and the one that's here now is like this. It's just showing you that you can use both types of right triangles. Notice that if this was one distance, then it would be the same distance over here because it's kind of making a rectangle. Same thing here, whatever distance we have on top will be the same on the bottom. So it's okay that we don't have this slope triangle up here. We can use the one on the bottom and it will give us the same thing. So I have this side, including point A. This is going to be my A side, lowercase a. This side, including point B, is going to be my lowercase b side. The same way that you found lengths A and B before, by subtracting. Subtracting either the x or y coordinates, you can show that subtraction using the variables. So to find the distance A, that distance A is vertical, right? So we've got this vertical line segment, which means we're measuring y values. So I'm going to take the y values and I'm going to subtract them. I'm going to take y2 and I'm going to subtract from it y1. It's okay if you put y1 minus y2 because technically distance is always positive. So if you learned from a few days ago that whenever you find the distance you subtract, you always take the positive value, which means you take the absolute value. In the same way that we found the length of A, we're going to find the length of B. This line segment is horizontal, which means that we're going to use the x values. So my x value of x2 minus my x value of x1. Again, we don't want the distance to be negative, so we're going to take the absolute value of that distance, of that difference. So what I'd like for you to do, now that we know that the distance can be found by subtracting and taking the absolute value of these variables, sorry, that keeps popping up. What I'd like for you to do is I'd like for you to substitute these expressions for A and B into the Pythagorean theorem. So substitute these expressions for A and B into the Pythagorean theorem. And you have space to do that underneath, but I had to go to a new screen because I don't have a ton of space. So my Pythagorean theorem is a squared plus b squared equals c squared. My A length was the absolute value of y2 minus y1. So I have y2 minus y1, and that's squared because it's squared in the formula, plus my b value squared equals my c value squared. So my b value was the absolute value of x2 minus x1. So I'm going to fill in, oops, sorry, x2 minus x1. Now, remember that absolute value means you take the positive value, but if you're squaring this content right here, this quantity, if you square it, you're going to get a positive value anyway. So these absolute value symbols right here are actually pretty redundant. So we're going to write that y2 minus y1 squared plus x2 minus x1 squared equals c squared. So that makes it look a little bit nicer. It's not necessary to have the absolute value in there. Now remember, to find the distance, and this is the distance that we're looking for, that's the distance c that we want. Remember that we're looking for the distance, not the distance squared. So this right here, this is not exactly what we're looking for. We want the distance, not the distance squared. Oops. This means that our first step when solving for the distance is to take the blank of both sides of our equation. Well, if you don't want c squared, you don't want this squared there, how do you undo a squared? The opposite of squaring is taking the square root. So you've got to take the square root of both sides. So we had this, and it's okay if these are x's now and these are y's. It means the same thing as this. Okay, it means the same thing. I can take a quantity and add another quantity in any order. It doesn't matter that they are switched. But now I need to take the square root of both sides and I need to solve for c. The way I do that is to square root this side and to square root this side. Now that I've square rooted a square, these will kind of get canceled out. They'll negate themselves. I'll have c equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And this, folks, is the distance formula for any 2 points in space. And you derived it, there we go. You derived it from the Pythagorean Theorem. The Pythagorean Theorem, along with the distance that you learned a few days ago, the absolute value of, the difference of 2 points, all of that comes together and allows us to calculate the distance formula for any 2 points in space. If you want to find the distance between 1, 4 and 3, 5, well, guess what? This is x1, y1, this is x2, y2, and you can take your coordinates, you can plug them in, and you will get a distance.